everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going from standard form to slope-intercept form using linear equations. So it's very important sometimes to go from standard form to slope-intercept form when we are graphing. So we want to clearly be able to see our y-intercept, our slope, so we can start at that y-intercept and move up and over for our slope. So whenever we're given an equation in standard form, we are going to be asked a lot of the times to give you the slope, give me the y-intercept, and you're going to have to be able to do that. So I always put it into slope-intercept form so you're able to give me the slope and the y-intercept, and that'll make it easier to graph. But I'm using these words standard form. I'm using the word slope-intercept, and you're like, what is that? So let's recall, standard form is ax plus by equals c, where my a, b, and c have to be integers. They can't be fractions, they can't be decimals. And slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. If we think about the two equations, we have ax plus by equals c and y equals mx plus b. The thing that's different there is we're having the x term on the other side. So using that knowledge, we're going to look at our steps. Our first step is to move the x term to the other side using our inverse operation. So if it is a positive x term, we're going to subtract it. If it's a negative x term, we're going to add it to the other side. So we're going to add or subtract our x term to be able to get that y by itself. It cancels out and moves to the other side. Then that y may still have a coefficient there. If it does, we have to divide by the number in front of the y. We have to think though, if it's like a negative y, perhaps, we have to divide by -1. I'm not asking you for negative y equals mx plus b. It's y equals mx plus b. We need the positive y by itself. So if there's a negative, you have to divide by the negative as well. When we are dividing by that number in front of the y, you have to divide the x term and the constant term by that as well. So our key points here is to move everything to get the y alone. We're isolating the y. Then we also need to divide all terms by the number in front of the y, not just one of them. Let's take a look at some problems to see how we would complete these type of problems. So for the first problem, we have 3x plus 6y equals 18. And our first step was to move over the x term using our inverse operations. Well, our 3x is positive, so we're going to use our opposite operation, our inverse operation of subtraction to subtract it over. So I'm going to have minus 3x, which cancels this out, minus 3x. And now we have this here. We have to recall that 18 and negative 3x are not like terms. One has a variable, one does not. So I can't say that this is 15x, for example. We have to keep it as two separate entities. So I get 6y equals, always put your x term first because slope-intercept form is y equals mx plus b. So x term should always be in front. Negative 3x plus 18. Now our second step was to divide by the number in front of the y. So I'm going to divide everything by 6. And I get y equals negative 3 divided by 6. We can simplify that. So if we can simplify it, let's do it so we get a proper slope. Just looking at this, you would say the slope is negative 3/6. That's not simplified. So that's technically correct, but it's not simplified and mathematically what we want to use. So if I divide both by 3, I get negative 1 over 2x. 18 divided by 6 gives me 3. So my final equation in slope-intercept form would be y equals negative 1/2 x plus 3. And this is proper because if we left it as a negative 3 over 6, we'd be going up 3, 6 to the left, and we'd be missing the crucial point if we went up 1 over 2 to the left. We're missing that one point in there. And this becomes important when we're graphing, especially at one point when we do systems. You might miss a crucial point that would have been their intersection. So always simplify your answers to be mathematically correct. Let's take a look at another problem. We have negative 4x plus 10y equals negative 50. Now I have a negative x term. Because it's a negative x term, my inverse operations tells me to add it over to the opposite side. So I add 4x, add 4x. I can't combine these two because they're not like terms. So I get 10y equals 4x minus 50. Divide everything by the 10 now in front of the y. So I get y equals 4 over 10. 4 over 10 can be simplified. I can divide out a common number, which is 2. So I have to do that. So 4 divided by 2 is 2. 10 divided by 2 is 5, so I get 2 over 5x. Then I have negative 50 divided by 10, which is integer, which is minus 5. And that's a much simple fractions involved. Our answer in slope-intercept form. 2/5 would be our slope, not 4/10. I know they're equal, but 2/5 is a proper slope, and negative 5s are y-intercept. Let's try one more problem to make sure we're fully understanding this topic. I have negative 2x minus 8y equals negative 30. Because this is a negative, I'm going to add it over to the other side. And I get negative 8y equals 2x minus 30. Now, because we have a negative in front of our y, we have to divide by negative 8, not just 8, because then we have negative y left. Even if this problem was just negative y, we'd have to divide by the negative. We want y, positive y by itself. So I'm going to divide by negative 8. 2 divided by negative 8 can be simplified. When I do that, I can divide both by 2, and I get negative 1/4 x. Negative over a negative is a positive, so I'm going to use a plus. 30 divided by 8, I can simplify that. I'm going to divide both by 2, and I get 15 over 4. So it's important to remember our operations when we're doing our integers, integer operations. A negative divided by a negative is a positive. A negative divided by a positive is a negative. This is important because when we're graphing, one little mistake will mess the whole graph up. So I hope all of this was helpful to be able to go from standard form to slope-intercept form when we are working with linear equations.